Okay, so on to the sim. So we have our points, and I'm just gonna so we can see them here. Just a little bit difficult. So you can see these points. What they do is they pop on and they stick. And you can see they're picking up the orient attribute, so they are they're pretty much locking to the surface. So, oh yeah, see that's another thing. Like, so if you need to actually lock geometry to a surface, that's when the attribute orient is comes in really handy. So there's our points, and they're going to go into, I'm just using a solver here. So I get this is the flow field, so this is the direction I'm going to be advecting. This is the closest point field. So, and yeah, as you can see, very basic. And we'll just rename these. Closest point field. Ew, ugly. Let's do lower camel case. Much better. Okay, so our first input is the points right there. And we have this switch here because we need the first frame. We can't look up the previous frame. So on the first frame, just pull in the geometry, and then on the second frame, the previous frame will work. So we want to merge these. And so all these points are going to be flowing across this. So this VDB advect points, the operation isn't constrained advection, so it needs both these fields. So there's our flow field, and then there's our closest point field that we built. And you know, that's what I really like about this is it's very easy to get going. Like, here we go. Here's some points flowing along our surface, already ready to go. You know, so there it's a very minimal setup, very easy to box up, and so we get some drips flowing along our surface. All right, so there's really not a lot to talk about that sim. It's just the advect points in a solver. The next step is the meshing, and so what happens in the meshing is you can see that it's really straightforward. It's just you take your particles, VDB from particles, do a little bit of masking from the collision object, and then convert to polys. Essentially, that's what it is. But you see what I'm doing here is when these particles accumulate at the bottom, like here, and then you can see they grow. So when they all reach the bottom, they're accumulating, and that is it's a pretty easy trick to do. So I'm just going to move forward, and so I set the P scale at 0.1, and I copy metaballs to it, and you can see how this geometry doesn't look too hot, but that's a representation of an implicit surface. So what we can do is we can use an attribute wrangle, and we can look at the meta weight. So we're going to look at the metaballs, and we're going to look and have the points look at the position. And what a metaball does is it copies this guy to each point, but it accumulates in this implicit field, so it all adds up the values. So this is a really great and quick way to get an accumulation buffer. And so as you can see, it adjusts the size of our particles. And oh, sorry, I use a VDB particle fluid, pretty much. Okay, so I'm going to enable that again. And so here's the attribute fields. I just pull them all down here. And I use an SDF difference, and so this pretty much just subtracts. And so you can see how this removes the surface So there's not really like interpenetration, so it subtracts. Then we just convert it to polygons, pretty straightforward. Color and an N. And so like I said, this isn't like this couldn't get through production. You'd have to do a lot more, but you know, it's just some fun stuff that I thought I'd share. And maybe, you know, with a bit more work, you can make a really robust drip system. So just overview, take your deforming geometry, Berry bind the points, compute attribute gradient field based on y, modify it as according to, you know, surface normals, you know, velocity of the object, whatever you want to do, multiply it, advect your points with VDB advect closest point, and then mesh and meta weight returns an accumulation buffer of some attributes. So thanks a lot for watching. I hope you found this informative, and thank you for all like the likes and the follows. It's really great to see that my stuff is helping people and you guys are enjoying it. So thanks so much. I really appreciate it. And of course, if you have comments or feedback, please let me know. Have a great day, guys.